Hello, everyone. Welcome back. Today, we are joined by a guest who has spent his career not just securing systems, but fundamentally rethinking how we secure them. Brad Geesaman is the principal security engineer at Ghost Security, where he's at the forefront of applying agentic AI to solve some of AppSec's oldest problems. With over 22 years in the industry, he co founded the cloud native security firm Tagbit, which was later acquired by Aqua Security and is one of the world's first Google Cloud certified fellows. From hardening Kubernetes clusters to his groundbreaking work on pipeline precognition, predicting attack paths before they ever exist, and now building AI agents to automate security testing. Brad has been on a constant quest to move security from a reactive chore to more of a proactive, intelligent function. Brad, welcome to the show. I'm super excited to have you here.
Yeah, thanks for having me. Really appreciate the chance to come on and chat this kind of stuff. I've definitely had a bunch of career paths in the past. I've done some AppSec pen testing. I've done some sales engineering, some capture the flag development, cloud security, and now AppSec, and of course with LLMs in the mix. So I've
Yeah.
done a little bit of a lot.
Yeah, no, absolutely. I think I've been following you and your work ever since Kubernetes days. I remember back then Kubernetes was you know s- just starting to sort of come on the scene where companies were moving more towards Kubernetes and cloud orchestration tools and whatnot. And I think there was a phase where there were a bunch of opportunities in the security space as well. So I remember I built like an open source framework that involved orchestrating a bunch of containers to do some scanning and all of that stuff. So
Mm-hmm.
I think I came across you. I think you were probably with Aqua Security back then, and then I've always wanted to speak to you and just kind of pick your brains on some
Yeah,
interesting topics. So yeah, super excited to have you here.
let's do it.
Before we can get started, is there anything else you want to share about what you're doing at Ghost Security? What Ghost Security is up to?
Yeah, just at a real high level, keep it short. We're using LLMs judiciously to help reduce the toil and surface risk in a meaningful way in the AppSec lifecycle. So we're just trying to take the toil away essentially as best we can.
Yeah, yeah. Maybe we can start there then, Brad. Right? Like, so when I've been an AppSec engineer pretty much all of my career, right? And yeah, there are so many activities that as an AppSec or product security engineers we do on a daily basis that are essentially things that could be automated. Without AI, and for the longest time, at least as a practitioner, I haven't seen these activities getting automated just because it needs that intelligence a layer to it, right? Whether it is humans in the loop or AI, right? So how are you thinking about, like, are you focused more on those manual activities, or are you focused more on things like DAST and SCA and SAS, right? Like these kind of scanning activities that again could also leverage some automation. So just kind of help us understand what how you're
Yeah.
thinking about the space.
Yeah, you're obviously living it, breathing it every day from that side. You know it all too well that you're really trying to surface signal and reduce the noise. And some of the tasks that are involved are fundamentally tricky to differentiate that. And so things like software composition analysis, like is this package, yes, it might be present, but is it in the code path? Is it exploitable? Is it attackable? And then what's the context? Is it deployed? Is it in production? Does it have sensitive data? All these layers of context that you, as an AppSec person or any security person looking at a thing, has to assess to go, do I care about this or not? And you have to be quite confident about that. So when you do that, take that as a thing. That's one column. Then you have secrets. So I have secrets in source code or secrets wherever. It's like, is that a real secret? Is it still valid? Is it deployed? Is it used? Is it in production? Like all of those things. You're doing that over and over. Then you layer on, static analysis. So I see, an insecure use of this function, or I have potential SQL injection, or what have you. And again, you have to load up the context. You have to go look at the code. You have to do something and then go, okay, and then go, is this app deployed? Is it in production? And you're asking yourself these same questions over and over because you're doing that to build the risk assessment. You're saying, do I care about this or not? Is it high enough risk or high enough severity that I should go fix this, go nudge somebody to go fix it? And then things like DAST are fundamentally probing reality. That's all well and good. You found something over here, but is it in the real production system? Is there a way I can exacerbate and prove without a question that it's in there? And again, it's like I have to know what target to hit, get the creds. I have to get the context. I have to know what payload I'm trying to send that is a good test and a negative test, and then make sure that that is a correct thing. And then when the code is fixed and shipped, know that it's fixed and shipped, and then retest. You're like, all of this stuff is like, these are work processes, but there's so many little challenges with every single one, and then you multiply it by the volume that you get, and you
Mhm.
multiply it by the lines of code that are developed now, generated in a lot of cases, and you compound that with the fact that on average for the customers that we talk to, most AppSec folks are outnumbered by developers 100 to 1 on average. I think the lowest I've seen was 10 to 1, and I was like, hey, you're lucky. There are folks that are
Mhm.
300 to 1, and it just is mind-boggling how much volume that you have to handle. And so when I think of toil, I think of those repetitive tasks that are preventing you from getting to the point of good signal that you can act on. So
Mhm.
that's where our main focus really is like, how do we get to the point where it's like, I believe this tool's output 99% of the time, or some high degree is not 20% of the time, that I can then use that and talk to someone to help get this fixed and prioritize, because I know the 5 things we should care about, and I've already sort of weeded out all the other things that aren't really that big of a deal.
Yeah, yeah, that's interesting. So, you've been working with LLMs and sort of ghost
Hmm.
security for quite some time now, right? And fundamentally, LLMs are non-deterministic, right? If you execute the same sort of workflow automation multiple times, it's possible you might get different outputs on every run, right? So, in your experience of having, been sort of building ghost security, what are some approaches and strategies that you found where it's possible to sort of bring in more deterministic outcomes in some of these LLM workflows? Like, is there something that you've found that works really well in most cases? Like anything that you can share along those lines?
Yeah, I can certainly share. Use LLMs as sparingly as possible.
Mm-hmm.
And I say that tongue in cheek because there are ways of doing like a demo where you could just have like an agent talk to a bunch of sub agents and get this workflow working, and it does the thing in a demo, and then run that 100 times, run that 1,000 times. How consistent is it? How much quality is there? And what tends to happen is that, and specifically in the security space, it's not like we're like crafting a marketing email or something where it's like words, or it's highly subjective, right? It's
Uh-huh.
like, did it, given the same input, did it derive the same output? That's the consistency, and the quality is how well did it write it up, or did it get all the details and things? And that's very hard to judge. And so if you're having it do the workflow, the chain of thought, the plan, and then it's following the task list, and it's doling out the sub agents, every one of those touch points is an opportunity for an inconsistency because of the probabilistic nature of LLMs. So depending on your use case, I stress is that you try to make the workflow, maybe you use the agent mechanism to sort of tease out a desired workflow, but then look at every single one of the tool calls, or every single one of the handoffs, and go, can I take that decision away from the LLM to
Hmm.
increase consistency, increase quality? So that the things that LLMs are good for, classification, identification, validation in code, or generating a code fix, are these little boxes that you put in, right? And you say, all right, I'm going to do all this heavy lifting so that the LLM doesn't have to. Why? So that it's a consistent input. And therefore, I can focus highly on the specific thing I want it to do. I want it to make a very specific decision, yes or no, prod, non-prod, or, what are you trying to do? But try to make it a very specific classification effort as best you can. And therefore, you will get much higher quality and consistency because you're putting blinders on the LLM. The moment that you
Hmm.
let it make tool calls, sometimes it doesn't call the tool, or sometimes
Hmm.
it calls the tool repeatedly and it gets into a loop. You're like, what do you, it
Hmm.
just happens. It's probabilistic. It's most of the time it works and it's amazing, but the thing that you have to try to do is get it to specifically say with specific JSON output or schema output, like yes or no, and then you can make decisions off of that. And then the second thing I'll say is evals, evals, evals.
Hmm.
How do you know that you're making a change to the system and you're like you're touching one side of it and you're breaking another side of it? Subtle changes in prompts can actually have quite wide-ranging effects. So you need a really good set of data, and the narrower your use case for each one, the more precise your data, the better the evals will perform. You will break them less often.
Interesting. So, yeah, I think you mentioned a couple of points there that they're both worth digging into a little bit more deep into. So maybe let's start with the breaking down a bigger sort of design or problem space into smaller chunks, right? And then going or basically using LLMs to start small, right, and iteratively.
Yeah.
And I think that's been my experience as well. Is if I try to throw LLMs at solving complex problems, right, without giving it context or without breaking it down, yes, it is possible that I'm spending way too much time. So, like, is that how your approach generally works? Is you have a problem and you break that problem down into as many individual pieces as you can, and then you analyze, okay, which one of these steps is probably apt for LLMs versus you could just write a function for that. Like, is that how you think about it, or is there more to it?
Yeah, that's exactly. There's a couple stages. Like if we're doing like a rapid prototype internally,
Uh-huh.
we've sort of adopted this idea of like, can I get a workflow as fast as possible to prove the outcome's value? So let's say I have a thing and I want to scan something and I want to do some LLM in the decision making process. I'm I'm trying to get to the question of, can I keep the focus low enough for this workflow or for this process so that the LLM is just doing this one thing and then it's feeding into something else doing this one thing. And I'm
Huh.
iterating as fast as possible. So often we'll use like Claude code with sub agents or open code, depending. And we'll just go, can I mock this up as fast as I can? But then as fast as that works, and you go, okay, if
Huh.
you give it the right context, it produces the correct output. Like that's a good thing we can make a security decision on. Then we go back to the drawing board and we go, how do I remove this? How do I remove this? How do I remove this? Well, this is like
Huh.
doing a file read. Why don't we just give it the file?
Huh.
Or it's trying to run around and search a code base or something. Why don't we search the code base for it? If it's doing this or this, or it's doing some sort of lookup or wants to do a web search, you're like, well, then why don't we give that just directly, or do a RAG in that case, and try to pick those things out so that it's fewer rotations or fewer loops on the calls. And it's like, here's your context, here's your thing, please do it, and that you can eval much more reliably because it's not making call, and then wrapping it all up and making a decision.
Yeah.
So that's what we're trying to do is like, yeah, prove the end to end is like, this is a worthwhile thing to try to optimize for, and then pull out all the basic stuff that, it's kind of cool seeing it go hunting around and pull,
Yeah.
wow, it knew to do that, knew that. Like, yeah, that's not going to do that 100% of the time. It's going to do that like 95% of the time. And that's
Yeah.
not good enough.
Yeah. No, I think, yeah, you bring up a very interesting point, and I think recently, I want to say almost over the past week or so, I've seen a few people tweet. Like, I think I saw Andre Karpathy's tweet yesterday, where he shared how his experience of this this ever evolving landscape has changed. And I think he mentioned something in his tweet where he was like, you know the way software is getting built is fundamentally changing now, right? Because we have this ability to generate as much code as we want, and if we don't like that code, we can just remove everything and we can
Hmm.
just start all over it again, right? Because it's
Yep.
not humans coding and trying out different POCs. And I think that's one thing that I really want to highlight is AI is really good at it, right? Like, we are not, we can sort of have AI generate multiple proof of concept codes of solving a problem, right? By basically specifying what we need to solve instead of how. And I think that's also something that is, it's very important to understand is, if you give the LLM context and explain the objective, the what, right? And just go let it do its thing by giving it some agency or what have you. I think you're going to get much better outcome as opposed to,
Absolutely.
describing exactly step by step, how and like all of that. Like, has your experience been along the same lines as well?
Yeah, it's funny, over the weekend I was doing a lot of diving in on Agent OS. I can give you a link for the show notes. It's
Yeah.
this uh concept of starting at the start and using the layers of your coding style, your best practices, and your product goals, and your vision for the product, and like putting this in the actual context. So it would be referenced in your Cloud MD or your Agents MD or what have you, and it has the specific style guides. It has the tech stack. It has all of the
Hmm.
background knowledge that you like. And I was just like, oh yeah, this is stuff that is just you would have to like verbally say to a junior engineer or a new senior engineer. It doesn't matter what their capability is. Coming onto your team, be like, this is how we do it. This is how we build. This is how we test. This is how we push. This is our PR nomenclature, our patterns, and
Hmm.
like it's codifying it into the repository. But then you layer on the PRD generation process. So a product
Hmm.
manager and product designer and a UX person could get together and express their intent and have it
Right.
be helped by the LLM to generate more thoroughly and completely. And then you're doing more of a review of it. But then that all feeds into, okay, break this down into task decomposition and go do this feature, then this feature. And it slices it up and it keeps everybody on the same track. And I find
Hmm.
that is incredibly valuable to going from stated goal and vision all the way to implemented feature such that it stays aligned because everybody's using the same mechanisms and
Right.
the same context. It's a
Yeah.
shared context. It's not a PRD over to
Yeah.
Google Doc and then this thing over to Notion, this thing over to Jira Ticket. It's in the code base. It's like everything
Hmm.
that you would ever need to know about how or why this project exists, and then how or why each feature got implemented and how the features were implemented in that order. And then as you keep going, it keeps pulling that context in as needed to like
Yeah.
reference and like, hey, you did it over here this way. Do that same thing again, but slightly differently, and make this next feature, and you get that much better outcomes. Like when you're coding, you're not like throwing away all that code that you mentioned. Now that was a POC example you gave, but like, I want this feature to look almost like that one. How do you
Yeah.
give it all of the context and intent and decisions? That's like, I think that's where the next sort of level up will happen is a unification of that context from
Hmm.
product to engineering and delivery via
Hmm.
those types of mechanisms because so much of it is code assist or LLM assisted code.
Yeah, yeah, I couldn't agree more with that. So essentially, what you're describing is, we specify the how in the, files like Claude.md, agents.md, or cursor rules, right? So those are the files where we can mention some of our security best practices or guidelines or what have you. So that's the how, right? But then when you actually go and start implementing something or uh, come up with a prompt to describe to LLMs what you want to build, you can just be, at a high level and let the agent figure out, right, how they're going to propose building that feature, right? Yeah, and I think that is also how we can bake in some security guardrails from the beginning, right? Like the whole secure by designs phase, where I think the way I'm seeing the world evolve is, even product managers, engineers, managers, right, they have started to, i I mean, you can call it vibe code, but still I think I'm seeing production grade code come out as well, and that's happening because they have good rules files, right? And I think that's
Yes.
basically the fundamental difference, where people still believe AI generates vulnerable code, absolutely, but there are ways to make it generate secure code as well. And I think the focus isn't being highlighted more on the other aspect of it, right?
Absolutely. It's fundamentally generating code on what it's trained on, but it can be steered in directions. It could be told
Yeah,
specific things. It'll go, oh yeah, I'll go add tests first. I'll make the
yeah,
test fail, and then I'll make the test pass, and I'll
yeah,
iterate until that's gone. Or it could just one
yeah,
shot generate, and you're like, depending on what you need, obviously there are pros and cons. A little bit more tokens, but you get the reliable outcomes. But
yeah.
then there's nothing saying that you can't do a security review while in the dev loop.
That's
So you
right.
had the code review, you had the feature, and then at the end, you're like, check for these vulnerabilities. Pull in the maybe the AppSec team has rules that you can just pull in and put that in the top of your code base. And when the security reviewer agent looks at it, it pulls that in and goes, hey, I should check for the following things. And maybe it was past issues with that specific code base that are brought in so that it knows not to repeat itself or make those mistakes when generated. Or just, hey, I feel like fixing some bugs today. Let me look at some of the security review things and go through that and go highlight some of those things and fix those proactively. Like there's sort of this just sort of in the AppSec loop. It's like a I ship the code and I'm done mentality, and then later a loop will happen or some scan or something will block a build or a scan happens that says, hey, go fix these things. And you're like, man, it would have been great if I'd known about them while I was coding. That like we need to get into that dev loop as much as we possibly can to stop the amount of work coming downstream if as best we can. So I feel like there's a nice
Hmm.
confluence of if we're using that context, we can feed into that context loop and get better outcomes straight out of the gate.
Yeah, yeah. Speaking about tools and frameworks, I think you mentioned open code. I've
Mhm.
I've also been sort of looking into open code just because Cloud Code is restricted to working with only Anthropic
Yep.
models. So, what has your experience been like? When do you decide when to use open code versus when to use Cloud Code?
It's the model switchability, basically.
Okay.
They're quite similar for most use cases. I tend to flip between Claude Code and Cursor personally, but I've been using Open Code and experimenting with it just because it has a couple things. It has similar functionality, but it has a different architecture. So it has a client
Hmm.
server architecture. And you can probably see
Interesting.
where this is going is like it's not married to a terminal interface.
Hmm.
And therefore it has a nice abstraction of that you can call it via its APIs. It has a RESTful interface. So, doing things that are headless in a sense, or more autonomous where it's agent flows defined in Markdown,
Hmm.
as opposed and called by an API versus having to like pull that all together yourself and getting all the benefits of the logging and the traceability and things that and also the model flexibility. Because
Yeah.
something that's very near and dear to my heart is this: the bigger the model, the more expensive, all that stuff. But like the privacy and the data governance is something that we still want to
Yeah.
solve for. And so I'm thinking more and more about how we can do things with local models and get the precision, get the accuracy for
Hmm.
certain chain of thought tasks or running tools, for
Hmm.
example, that doesn't require a beefy LLM. It just, follow this task list, call these tools in this order, and, use the output, and how to do that in sort of compact, private ways. Like, so if you have your
Hmm.
internal GPT hosted on Bedrock, or you have local LLMs, you can, do more workflows that stay inside your organization.
Got it. So this is also an interesting conversation. So basically, when you prototype something, right, do you start by using the frontier models like GPT-5 Sonnet, and then you try to optimize it by making sure that you're only using the frontier models when it is absolutely needed? Or do you start by prototyping using local models first and getting to, let's say, 80% of the way, and then trying the same workflow with these frontier models and seeing how to improve? Like, what is your approach like?
Yes. Both. It
Both,
depends
yeah.
on the task, right?
Mm,
Like I mentioned that prototyping mechanism where it's like quick, fast, dirty, and like get to the
yeah.
value. That's typically with a frontier model. But then there's like I want this to run in a specific context. Then it is an immediate. Does that same thing work? Maybe with some additional tweaks. Does it work with a local model, maybe like a GBT OSS or something, or Llama 770B or something on a beefy laptop? Can it do that? Can we hit that bar, or is it just the quality is not there? Because that's
mm,
sort of it, like what you're looking for in a rapid prototype is to get to know as quickly as possible. Like if it's yes, and if it's yes, if it's yes, it's like, okay. But if it's a no, I want to know early that it's not going to go and I need to try another avenue.
mm,
So if there's a strong requirement that there's a local model, typically it's I want a rapid prototype of something because we have all the tooling that we have that just works easily with the frontier models and go. But then it's like, okay, fire up LM Studio, get the model going, get the temperature set, and do whatever, and then
mm,
say, all right, does this translate? I would say I rarely start with the local model because it's more of like, does this work at all the way I expect? The interactions, it's often quicker, but then to see what the performance is. The tokens per second affects the latency, affects the feel,
mm.
and that's sort of like the second tier set of things I want to check before going forward.
Got it. Do you use LM Studio or Olama? What tool do you use locally for
Generally,
the local
LM
models?
Studio, I kinda like its, features, the model interface. I mean, Ollama's great too, like, it really, um, doesn't really matter, we'll say. I
Yeah,
just have a MacBook, so that has the MLX support. I don't have to think too much about it in LM
nice.
Studio and, makes it easier, but, yeah, either one will do, like, it's just sort of a preference thing.
Got it. And is there any of your favorite models that you run locally?
Well, let's see, what's the latest? I was playing with some of the Quens because
Quen
they're coding.
Coder? Yeah, yeah.
Let's see. Obviously, the GPT OSSs are very interesting. The Llama 4 Scouts. So I like the ones that are like between 20 and 30 billion parameters are
Okay,
sort of the interesting, like, not sweet spot, but I'm trying to, if I can get things in that means it'll run in most situations on a single graphics card or what have you. But the Quen 330Bs are very, very interesting.
got it.
Um,
Have
yeah.
you played with any of the DeepSeek coder models?
A little bit. A lot of the tasks that I have are like reviewing code, or not so much code generation, but a little bit of reviewing code and a lot of instruction following. So I
Uh,
liked having some of the coding expertise in there, but it's just like who's following the instructions the best. And often small models can do really, really good job
yeah,
there.
yeah. I was trying DeepSeek Coder 7 billion, I think, the other day, and it did surprisingly well. As compared to Sonnet 4, I'm like, wow, if this local model, right, for free of cost, can almost match,
Yeah.
right? Like, yeah,
Yeah, I find the couple of things, I don't know what language you tend to develop in, but the languages that are strongly typed or statically typed
uh,
tend to have the linting help assistance. So if you're, a JavaScript, TypeScript kind of person, sometimes it's a little bit harder. But if it's like Go or something, it's like
yeah,
it's pretty like clear. That is an unused variable. And the LLM's like, oh, let me go fix that. And so there's a
yeah,
lot of these little micro infractions that get automatically resolved depending on the language and the linting feedback they get to make sure that it stays on track. So I
uh,
find that some of the local models do better with those types of languages as well because it's more direct and it knows, or can work with that feedback more directly.
yeah. Got it. Cool. All right. So I'm gonna take a step back and get back to the
Mhm.
2 points that you mentioned before. The other point you mentioned was about evals. Now, evals is an area that I myself don't understand, well, and I'll be the first to admit that. So help me understand, right? Like when you start building a prototype or whatever you're doing on a daily basis, how do you think about writing evals and how do you think about implementing them? Maybe give like a quick primer about how to go about doing evals.
Yeah, really at a high level, it's about, trying to achieve quality and consistency by having a data set that you go to that is representative of your problem space. So if I'm trying to, I'll give a really quick example is like classifying a host name. Is it prod or non-prod? Just the only clue you have is the naming convention of it and what's the confidence level, we'll say, of that. And so
Uh,
if you're trying to make like a host name classifier, what you're fundamentally doing is trying to capture 1,000 true like classifications. Like that is, a human has done it, or in some cases in the LLM world, it's synthetically done, but that it's classified. And then you're saying, okay, I'm going to run it through this process, an LLM call, and I want to see, is it also matching the same result? How often? And what changes am I making to the overall system that affect this? And so an eval is basically just like rerunning this repeatedly with multiple reps to say, 4 out of 4 times or 5 out of 5 times, this LLM setup, the prompt, the tool call, whatever it is, this configuration has said that it is a prod host name 4 out of 4 or 5 out of 5 times, and that is an accurate answer. That's
uh,
perfect. Like that's a perfect
uh,
score. But sometimes it's 4 out of 5. Maybe that's
uh,
okay. It's okay
uh,
for it to be pretty close, or it has a reasonable confidence. But what if it's like I make a change to the prompt and all of a sudden it goes from 5 out of 5 to 2 out of 5? Ooh, that's not so good, right? So how do I measure that? And what you're trying to do is get a representative sampling, because you can't obviously have millions, but tens of thousands or thousands that you can run every time you make a change to the prompt, the system prompt, the user prompt, the agent setup, to be like, am I still getting the required quality and consistency that I want? And so when
Uh,
we apply that to some of our findings, what we're doing is we're taking a wide range of findings and the representative input and context, and we're saying, given the prompt, given the combination, did you come up with the same result? And it was, 5 out of 5 times across all of the finding types, across all of the issues. And so that's how we sort of like, that's a small example, but that's how you would extend that is it's expensive. Like, depending on the
Number
prompt
of
size,
calls.
it could be
Yeah.
quite a few dollars, but that's what you need to do for a system to be able to be repeatable and reliable.
Interesting. So, and then at what time do you do these evals? Is it like when the new frontier model comes out, you want to see if you upgrade your model from, let's say, GPT 4.1 to GPT 5, is it actually improving your overall system? Like, are those situations when you actually do your evals, or is eval something you do pretty much on a regular basis?
We do it very routinely. So anytime there's a significant change, and I say significant is like I added a sentence to a prompt.
Okay.
Right, like if I changed a typo, typically I'll run it locally on a smaller number of iterations, but in
Hmm.
CI, when you say, "I made a change to the prompt," tick off the run the eval suite for that harness or that piece of the stack, we'll rerun it because there's been cases where it's like I add one extra piece of you know, context, like think hard about this or consider this, and then dramatically affects the outcomes. And not dramatically, but like all of a sudden the severities are different or something like that. And you're like, whoa, I didn't intend to have that side effect. Revert the change, rerun the evals. Okay, get to the back to the desired, and then iterate again and make sure that we stay within our quality boundaries. Right? It's never going to be perfect. That's the
Uh,
non-determinism of LMs, but you're just trying to go for a very specific quality score, consistency score, and just stay above that.
got it. Okay. Uh, Let's move on to something more
Yeah.
interesting. Context engineering. I think you've mentioned context a few times, and I know Go Security also introduces concept of CAST or I don't know
Mhm.
how you want to say it, but it's contextual application security testing as a successor to SAST. Right? What does context mean in this new paradigm, and how does an AI agent acquire and reason with that context in a way that a traditional SaaS engine cannot?
Yeah, so for us, context is obviously the key. And so instead of say tools that are just doing like pattern matching and presenting a candidate for either a human review or an LLM to sort of figure out the rest, we flip it. And instead, we look at the source code repository and we try to build up the construction of the call path of every endpoint. So it has the entry point, the handler, the middleware, the models, all of that good stuff that comprises this specific endpoint. Then we're able to classify that endpoint. Is it enforcing authentication, enforcing authorization? Is it handling sensitive data? Is it calling databases? Is it calling LLMs? Is it calling external URLs? Any type of label that we want to annotate. And then from there, we can ask any good question we want and therefore run any agent we want on that set of context. So we're front loading the context. So instead of
Uh,
going, let me look at a pattern and go, let me find the context around it to see if this is useful, we're focusing on, no, 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 let's break down and get the context. And then we're focusing the questions that we're asking of that data right into what it needs to be. We already know it's an endpoint that's exposed. It has these characteristics, it's authenticated, et cetera, or not. And that can drive, it takes user input or not. And that drives the decisions that feeds into the agent. So
uh,
as a like flipping it, I mentioned about like we try to take out the non-determinism part is we build up as
yeah,
much of that context as we possibly can
yeah,
deterministically prior to feeding it into LLMs.
yeah.
And
Interesting.
that's how we see the code base in a much more deterministic way, really.
Got it. So I guess one thing that comes to my mind is with this kind of approach, it has to be expensive, right? Because now that context gathering phase initially on would mean that you're issuing multiple API calls with LLMs, all of that stuff, and then B, it's going to affect its performance as well, right? Like the overall experience has to be a bit slower, right? Because you're not
Mhm.
just trying to solve the problem, you're trying to first gather the context. So how do you balance that trade off here?
Yeah, so the without getting too much into the secret sauce, because
Yeah,
there is a
you don't.
concept of partial scans based on things that have changed and things that haven't. I will say that that is the predominant way to get uh,
Uh,
'cause, costs down. But you mentioned the latency is we're going for the deep and accurate. We're looking for
uh,
things that are typically our customers say are found or they get their highest signal from a human-led code review, a pen
uh,
test, or a bug bounty. So we're focusing on those vulnerability classes. And so, you know, those are extremely slow feedback loops. Those are weeks at a time, and we're doing it on a daily basis. So what we're trying to do is give the context to the AppSec team repo wide, fleet wide across all the repos that have the apps and say, this is the state of your very complex, very tricky business logic type flaws, in addition to all the other basic table stakes features. That these are the classes that are hard to find because these are the business logic flaws. This is why we broke down your app this way, and this is why it takes sometimes between 5 minutes and 2 hours, depending on thousands of endpoints. And we're looking for different things in different endpoints based on its tags. So that's why it might take a little bit longer, but on the AppSec life cycle, if I'm an apps, I don't necessarily need every single commit. And that's our trade-off that we make is we don't scan in real time, but that gives you the deepest amount of understanding and ability to like make more strategic decisions. So with the Toil, then moving to the Toil, let's say you have high quality findings about all of your repos that are really hard to find otherwise, that maybe you would only have found from a pen test. What's your next problem? Is like, well, what do I fix first?
uh,
And so then there's the whole nother layer of tactical assessment, remediation plans, and like if I were to put a middleware here, I solve all these bolas. If I were to put authentication here, then I take care of all these endpoints that are unprotected. Or if I have SQL injection, I need to use an ORM or something along those lines that is like a more leveraged solution or a leveraged fix. And we're trying to get AppSec teams into that spot where they have a
uh,
really good understanding of things and that they're leveling up and going, all right, we have problems. All of our Java apps suffer from this same pattern. How do I go and solve hundreds of issues with one? And I think that's what like sort of the vision here is, getting you out of the trenches and into looking forward and looking ahead strategically.
got it. Uh, Curious to get your thoughts and opinions on fine tuning, right? Especially with, when it comes to security, engineering, finding vulnerabilities, right? I've heard from multiple people that instead of using any LLM, you can take a SLM, right? And you can sort of train it, you can fine tune it, right? And again, this is an area that I'm trying to learn about it myself. Kind of curious to know if you've had any experiences going down this route, any strong opinions about whether we should do fine tuning or not, or whether we should just kind of go with LLMs and see how far we can get.
Yeah, no, that's a really good question. Like, I like what you just said at the last part. How
Uh,
far can we go with the larger model and
yeah.
a cost benefit trade off that still works? Because there's pros and cons. I have not done a lot of tuning. I've done a little bit, like classification things to learn how it works.
Uh,
The cost and the sort of the baking in and locking in or the capability is potentially a pro, potentially a con for new language support, new framework support, all the things that are like the frontier models are constantly being trained on more and more code. They get better at seeing the patterns. And so if you bake something in or fine tune something into a model, you're sort of stuck at that point, frozen in time, versus sort of riding on top of the advances and innovations that the large models do. So,
uh,
for example, when they drop their prices for a new frontier model, and all of a sudden the cost dynamics stay very attractive, you're
yeah.
trading a little bit of premium on the tokens, but you would be spending that time in the fine tuning land and constantly retraining loop. So it really depends on volume and how much
Uh,
flexibility you need. So if you don't need a lot of flexibility and you're like, I have this one specific image classification task, I have this one, the classification of host name is a good example is like, yeah, absolutely. You could fine tune that in a small language model and run that off of a mini uh, Raspberry Pi or something, right? But
uh,
if it's like, I need to do complex code analysis over this graph stretch, the strongest models will do the best. And I hope that in the near future, that
uh,
the large models will keep going, but they will reach a point where many of the tasks that we need are solvable by the medium small models that we can then tune a little bit, and the cost of tuning, the cost of retraining comes
yeah,
down to where that benefit is traded off well, and we can have more focused on that. But like, it's just amazing how much better each model generation comes out at doing some of the tasks. When you run your evals,
yeah,
again, you could see the consistency and the quality. You can use even some of the smaller frontier models to do what the prior best one was,
yeah.
and that's really exciting. So I think it's obviously there's trade offs there, but yeah.
Yeah, yeah, and I think going back to your previous point about breaking a bigger problem into smaller pieces, I think I see a future where it would be possible to execute these individual sort of workflow steps with different models. Like
Yes.
some could be done by LLMs, some could be LLMs, some even local models, right? Do you believe
Yes.
that is where we are kind of heading towards?
I hope so, and I believe that's
Yeah,
where we need to go.
yeah,
There's sort of, there's externalities and unsustainability of running, the large language models for the sort of tedious tasks. Like, there's a fitting problem of like, you ask it everything, and that's not really the most efficient use of the large language model, is that often it's hard to know when you can get the quality up to be able to run on a small local model and
uh,
when you should do that. So I'm very like hopeful that in the next 1 or 2 years, there's going to be a shift to easier tuning, easier training, like distillation processes that really make these, 7 billion parameter models exceed what they need to be for what they are. And they can run
uh,
on much smaller compute, and also the privacy and the locality and the governance things come along with that. So that's where we need to go, I think, as a, as an industry, really.
yeah, interesting. Um, in terms of competition, right? Like I see so many new companies trying to build innovative solutions in order to solve some of these AppSec problems, right? SaaS, DaaS, what have you. Uh, in your opinion, right? Like, what are a few things that uh, you ought to be doing? Maybe you're already doing at Ghost that will sort of make you stand apart from your competition. Is it about context? Is it about something else?
I mean, certainly context is part of it. I I feel like I come from a consultative background,
Uh,
and I've done a lot of that. And so every time we talk with a customer, I find it's an opportunity to understand where they are. It's one thing to say, I have this solution that will solve everything, but maybe they're at a not as far along point, and you need to be real about what their needs are at that point in time. And I think solutions that are flexible to where people are, like, there's not an assumption that everything is perfectly deployed this way or their code base is arranged a certain way. Like, you have to be more flexible to that, and not just on the happy path. And I think the folks that are able to make the deployment and the maintenance of these tools orders of magnitude better than the prior generations of tools or prior approaches that the customer is using, that's what's really going to separate folks. Because if it's just an incremental improvement, it's almost not worth it because there's so much organizational friction of ripping out and replacing.
yeah,
But if you slot in nicely, you integrate nicely, and you provide extraordinary value, also to all shapes and sizes, right? Not just startups and not just big enterprises, but you're flexible across the board. I think that's where you're going to have success. Um, yeah, that's what we try to do here, of course, but, I feel like, there's sort of a gravitation towards, like, the very, very bleeding edge, and I think that's missing some of the folks that are 3 or 4 years behind state of the art because of just how their organization is, and like,
yeah,
those are the most core businesses that run things there that have the same vulnerabilities, sometimes more than anybody else, and they need the help too. But it sort of needs to fit into their shape as well. It can't be just only the brand new things that work for them. Sometimes you have to go on prem and things. So
Yeah, and I think that would also explain why big name vendors like Sneak and Checkmarks and Veracode. I don't know. I'm kind of throwing a bunch of names out there, but I think uh, it's going to be tough competing with some of these new age AI native SaaS companies and whatnot, right? Because they are sort of purpose built, and they know what their ICP is. They're going after the right customers, and yeah, I think for some of these big name vendors, it's kind of going to be difficult to bake in those AI native capabilities that just works out of the box. So I
I
think that
mean,
aligns. Yeah,
yeah. No, I was just gonna say, I think when you have a customer base, you also have inertia, right?
that's
And
right.
it's hard to change your direction and retool and recalibrate and reimagine something that maybe is counter to the
Uh,
value proposition you currently use. And I'm not saying that they aren't able to do that. It's just harder, right? And so
uh,
it's a little bit of a hey, with new capabilities with LLMs, if you can harness them correctly, you can add efficiencies here, and here, and dramatically improve outcomes, of course. But if that is sort of counter to the current approach that you're already, deploying and have a wide deployment base, it's sort of hard to balance that and message that. So, but yeah, like I don't begrudge them having large customer bases with revenue streams and being able to do great things. It's just we're
yeah,
thinking of like, what's next? What's the next group of vulnerabilities that are super hard to find, and how do we find them and surface them because they're so prevalent, and how do
yeah,
we do that efficiently? And I
yeah,
think that's where I get excited every day because that's what we're
yeah.
focused on.
No, absolutely. And I think it's also a matter of what can we find using LLMs that we could not have found before. I think especially with complex business logic issues,
Yeah.
authorization issues, right? I think we've all sort of validated this hypothesis that LLMs are actually good at finding these complex issues as compared to deterministic SaaS engines. So I think there's going to be a place for both, right? Like big name vendors and smaller companies, and I think they both solve like individual pieces. So absolutely.
Yep. Yeah.
Okay. I have a bunch of questions, but I know we are getting close to our 45 minutes. So I'll maybe, end with just one question, and you can take this in whichever way you want. But based on your work building these advanced systems for so many years now, what is the single most important skill, technical or a non-technical, that the next generation of application security engineers should be cultivating right now?
Yeah. The obvious answer, I guess, is being comfortable with LLMs and knowing their pros and cons and when to use them and when not to. But I think the true unlock is when teams ask, like, how can we build scalable workflows that just aren't my workflow? Like, as an individual, like make a report come out this way, but something that works for the team. I think back to the DevOps revolution of like, we're trying to ship code efficiently and safely here. I'm building the code. How do I get it to you ops so that you can run it and you know what's going on? Well, there are containers and there's automation, and let's have this come out of a defined CI process and maybe even CD. And that's how we ship code. Like, let's agree on that as a complete end-to-end workflow. Maybe there's testing involved in whatever. And let's have defined points, right? Defining your systems with these LLMs, it's very easy to make a whole bunch of things that live in isolation. It's sort of like the next generation will be systems that communicate with each other to get context. So you have, the SaaS platform, and they can share information with each
MCP.
other as needed. Exactly. That is both done well. There's
Yeah.
challenges there,
Secure.
of
Yeah,
course.
yeah, absolutely.
Yes, and traceable and auditable and permission
Yeah.
locked and all that good stuff. But like that, these systems are interoperable. So it's not just like I'm
Uh,
solving for my AppSec needs. I'm solving for the security organization. Very often we get told, "Hey, we want to be able to, from a SOC event,
uh,
go look something up from the app context." We're like, "Oh yeah, of course, that makes complete sense." And same thing is like when we get something, we might want to pull in some cloud context as an
right.
example. So like, where do we get that, and how do we make that as seamless as possible? So if I was to like be an AppSec like senior developer, I'd be like, or engineer, I'd be like thinking with the security team, but also the development team, like how do I fit into that workflow and make myself a producer or a provider of context because I have the expertise to have that system be, full of it and high quality, and they might not, but they would love to be able to benefit from it. Like look up a URL, like what have you seen?
Yeah.
Are there any vulnerabilities on that URL? Which would be in response to a network incident, for example. Like that's the kind of sharing. So that if I were to say that skill, it's sort of a mindset, I think, is to make sure that your systems are working with the cohesive unit and not just completely siloed.
Yeah, no, wow. I didn't think about it that way, but it makes so much more sense because, yeah, I think this is very thought provoking in the sense that AppSec engineers, fundamentally are supposed to be these engineers who kind of glue, like act as glue between
Yeah.
engineering teams and, infra teams and whatnot, right? And for the most part, that's not what we end up doing. It's because we end up, doing design reviews or threat modeling code reviews, right? Yes, there might be situations where we have to work with teams, but that's not the focus, at least from my experience, right? And I think what you mentioned makes a lot of sense that the way the world is evolving towards, it's more about integrations, it's more about agentic sort of different agents working with each other, company agents of a company working with agents of company B, right? So as a security engineer, it becomes really important to understand how sort of the entire life cycle of product works, from the design stage to sort of
Yes.
deployment, right? Everything, right? And I think integrations is going to be very key. So yeah, no, I think this is very thought provoking, and I'll continue to ruminate over it. But yeah, Brad, thank you so much. I have no idea how the past 50 minutes have gone by, but I'm gonna have to have you again here just because there were a bunch of other questions that I wanted to go into. But
Sure.
regardless of that, thank you so much, Brad. We really appreciate your time.
Yeah, really appreciate it. Thanks for having me on.
Thank you for joining us. If you like the show, please share this with your friends and colleagues. If you have any questions or comments, you can reach Anshuman on Twitter at Anshuman_BH. That's ANSHUMAN_BH. And me, Sandesh, at Jubba on Jeans. That's JUBBAONJEANS. See you next time.